evening and welcome. It's Monday, it's time for the mathematics news. This morning I just want to do a quick video to do a bit more explanation about the median and the interquartile range, because I'm going to set you some work that involves the median in particular, but also the interquartile range, and I want to make sure you can do that for different groups. It depends on how many things there are. I've got three sets of data here, one for the height of frogs, one for the height of chickens, one for the height of ants. I collected all this data this morning, very accurate. But there's a big difference between these three different groups. It's how many there are. And the number of items makes a difference to where the median and where the quartiles are. So it's worth considering the difference. And the main difference is between even numbers of things and odd numbers of things. And you treat them slightly differently. So the number of frogs. There are 1, 2, 3, 4, 5, 6, 7, 8 things. So n, which is always the number of things in a group, in statistics is 8. This one is chickens is 1, 2, 3, 4, 8, 12. So n is 12. And the ants, I think I've got 4, 8, 12, 13, 14, 15. So n is 15. And if they're even, you always get 2 in the middle. And if it's odd, you always get 1 in the middle. So this is easy to find. But it also makes a difference. If you're finding the lower quartile and the upper quartile, you're looking for the median of the top and the bottom half. So it's not just whether this is even, it's when you end up looking in the lower half and the upper half, if that's even as well. And you treat these two things slightly differently. So what I'm going to do is I need to put them in order. These are not in order yet, so I'm going to put them in order now and probably speed this up. Okay, so let's have a look at the values of the medians. And if there are an even number of things, I'll have to take the mean of those two. So frogs, we've got lowest, highest, lowest, highest, lowest, highest, and then these two are in the middle. So the mean of 3.7 and 4 gives me 3.85. That's the median, but I'll call it Q2, 3.85. For the chickens, we've got lowest, highest, lowest, highest. 2 in the middle here. The mean of those two will be 37.5. Okay, for the ants, just 1 in the middle because there was an odd number of things. So here the median is 0.13. So these two are both odd, so I had 2 in the middle, and I take the mean of those two. This one is just straightforward, it's just 1 in the middle. Now, if I'm going to get the lower quartile and the upper quartile, I need to concentrate on the lower half and the upper half. Now, you treat these two differently from this one. Because there's 2 in the middle, we're going to split it in half like this, and take the median of these ones and the median of these ones. So we're including the ones we were using for the median. The same would go for the chickens. I would cut it in half like this. But for the ants, what I'm going to do is I'm going to delete the number in the middle. I'm not going to use that and use these ones as the lower half and these ones are the upper half. So it really depends on whether you're dealing with an even number of things or an odd number of things. And then you find the quartiles. And the quartiles are the median of the lower half and the median of the upper half. So for the frogs, this should be relatively easy to carry out. I've just got 3 up here, so I've got the lower quartile, which is the median of the lower numbers, is 3. And the lower quartile is usually written as Q1. And we've got up here Q3, which is going to be the median of these numbers. Hold on, have I split that right? 1, 2, 3, 4. 1, 2, 3, 4. I should have had 3 here because there was 2 of them in the middle there. But it is 3. This one I've got 5 and 6, so that's 5.5. Down here I've got the chickens, I've got 1, 2, 3, 4, 5, 6 numbers, including the 37. So the median is going to be these two of those ones. So the lower quartile of the entire group Q1 is 33.5. And up here we've got 1, 2, 3, 4, 5, 6 here. So it's going to be the third and the fourth one here, 39 and 40. So that gives me 39.5. Q3, 39.5. And so it really depended on whether I include this one or not. And if you didn't include this one, you would get a different number. Here you would have got the same number, but if you do include this one, you have 6 numbers. And when you're doing lowest, highest, you have 2 in the middle. So it makes a big difference whether you include these or not. But if it's an even number of things, you do include them. If it's an odd number of things, you don't. So here, I'm not using that 0.13. I'm just using the lower quartile. It's going to be the median of these numbers here. So lowest, highest, lowest, highest, lowest, highest, that one. So Q1 is 0.1. And of these ones at the top here, I've got lowest, highest, lowest, highest, lowest, highest, and I'm left with 0.18. So that is Q3, which is 0.18. Once I've got all the quartiles, which are the median of the lower half and the median of the upper half, I've also got the median of the entire group. I can then compare the different things. Here I can work out the interquartile range. It's the difference between Q1 and Q3. So for this one, the interquartile range is 2.5. That's for the frogs. For the chickens, the interquartile range is 39.5 minus 33.5, which is 6. And for the ants, the interquartile range is 0.08. And now, once we've got all this information, we can start to look at the difference between these groups. I can see that the medians give me an idea of the size of the average of these. These are the heights of these different animals. So on average, the frogs are 2.5. On average, the chickens are, sorry, not 2.5. The frogs are 3.85. The chickens are 37.5. And the ants are 0.13. So you can immediately compare the medians and say the chickens are biggest and the ants are smallest on average. The interquartile range gives you an idea of how spread out the data is. So we have the frogs have a spread of 2.5 centimeters, the chickens have an interquartile range of 6 centimeters, and the ants have 0.08 centimeters. So these guys here are much more similar to each other than the chickens. The chickens number is huge. So you have some big chickens and you have some small chickens, even within the middle half of the data. If you notice in the ant data, there was a big ant here that was 0.4. By using the quartiles and finding the interquartile range, we're ignoring the biggest numbers and the smallest numbers. We're just focusing on the average half of the data, which in this case is 0.08. The average spread is the middle half of the data there. So you've got some exercises to do on my iMaths. I'm going to take you some more work on Manga High. The details are on your homework. And good luck. I'm online if you need some help. From the Mathematics News Desk, good evening.